Okay, this video is just to quickly explain how to do energy level diagrams. Tiny bit of background. I always see these as a more detailed version of the Lewis dot and cross diagrams that you're taught in chemistry. So in chemistry you're taught that, say this is my oxygen atom. I'm not sure if you're taught that it's oxygen 816 or whether you're told that it's 8 protons and 8 neutrons in the nucleus. I don't think that, I'm not really bothered about that. I'm interested in the electron energy levels now. Here it's got 8 electrons, so I've got 2 in the first shell and I've got 6 in the second shell. But it's entirely sensible that there would be other shells that these electrons can be pushed into if you give them energy. And that's what we do with our discharge lamps, and when we put chemicals in flames and things like that, we give the atoms energy and the electrons then can transition to higher energy levels. Okay, so if you imagine, and there's a very good diagram of this on the BBC website that I've referenced on our stream, and where you can see there's a lot of these. And so what I would do then is say there's not an infinite number, but there's a lot, but they are not infinite by any means. Obviously, the only way in which you could technically give an electron enough energy to completely leave the atom and ionize it, and then it can have any energy value. So that would be true. Now, and what we basically do is take a slice through this and say we want to represent this as a vertical diagram. So I'm going to say, okay, that's fine. I want to take this across here. I'm going to lose the curves and say, okay, I've got some ground level, which is the lowest. We sometimes call this the ground state, which is the lowest energy level that an electron can exist in. And then above that, I've got, in this system, I've got 3 energy levels. Okay, so I've got my ground state. I've just realized I've gone off the diagram. I've gone slightly bit off the. So I'm suggesting I've got a ground state and I've got my various energy levels. And this is important. Ground state, you cannot have an electron having lower energy than that existing in that atom. So what can we do with these electrons in the various states? Well, let's move on to electron transitions. So there are only certain allowed transitions that an electron can do. So here we have our set of energy levels. And so this one would be the ground state. Ground. And if, just for the sake of argument, I populate a lot of these electrons at the top of the page and say I've managed to put them all on this top energy level. Now, there are reasons why you can only have certain ones in certain energy levels, and they are quite interesting quantum mechanical reasons that they won't discuss in chemistry, but I won't overcomplicate things now and suggest that, let's say, the options for this electron are it can fall down all the way down from this energy level. So if I call this, it can fall all the way down to there, or from here, it could fall down to there, or from here, it could fall down to there. Now, if it happened to be here, having maybe done one transition, if it was at this point, it could then decide to transition all the way down to the bottom.
Sir.
Yeah. Can you just give me just 1 minute, Chris? Or from here, it could transition just to there. And then from here, it could transition to there, and there's no other option. So I've actually only got 1, 2, 3, 4, 5, 6 allowed transitions. So that's how you do the allowed transitions.